So section 12.2 and 12.3 are going to be a little bit about statistics, guys. It's just two sections. There's not a lot here, but the problem sometimes can be a little, confusing. So I really want to go through these in very detailed manner so that, we can understand what's going on. Okay, so in 7.2, we talked a little bit about frequency distributions, like a frequency table and a histogram. So we're going to kind of revisit that same idea here, and it says it's not uncommon for statisticians, and others to have to analyze thousands of pieces of data. So a piece of data is a single response to an experiment, and the word data is also plural. Let's see. When the amount of data is large, it's usually advantageous to construct a frequency distribution. So a frequency distribution is a listing of the observed values and the corresponding frequency of occurrence for each value. So let's go through this problem here and see if we can't figure it out. Okay, so it tells me here that this sort of piece of information is the number of children per family is recorded for a total of 64 families. And it's asking me to construct a frequency distribution of the following data. So I want you to look at the numbers that we have here. The individual distinct numbers we have are the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? What we're going to do is we're going to count the number of zeros, the number of ones, so on and so forth. So guys, let's see. This piece of information here, this is 8 by 8. So there's 8 numbers going down, there's 8 numbers going across. So if I was going to count the number of zeros, there would be 8 of them. If I was going to count the number of ones, there's 8, 9, 10, 11. Okay. If I'm going to count the number of twos, let's see. Here I already have 8. Let's see. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There's 18 twos. Okay. If I'm going to count the number of threes, there are 8 threes right there. 8, 9, 10, 11. So there's 11 threes. Okay. If I'm going to count the number of fours, let's see. It stops right here. That should be 6 fours. Okay. Count the number of fives. 1, oops. My pen going again. Okay. 1, 2, 3, 4. So there's 4 fives. Count the number of 6, 1, 2, there's 2 sixes. There's only 1 7, there are 2 8s, and there's 1 9. Okay, so let's see what that means. That means that there are 8 families that have no children. There are 11 families that have 1 child, 18 families that have 2 children, 11 families that have 3, 6 families that have 4, 4 families that have 5 children, 2 families that have 6 children, 1 family has 7 children, 2 families have 8, and there is 1 family that has 9 kids, right? That's what all that's telling me, okay? That's all the frequency distribution means. So I'm going to scroll down here, and it says, often data are grouped in classes to provide information about the distribution. That would be difficult to observe if the data was ungrouped. So graphs called histograms and frequency polygons can be made of group data. So let's see. So it says these graphs will provide a great deal of useful information. When data is grouped in classes, certain rules should also be followed. Okay. So the first thing says every class should have the same width. Okay. What do we mean by the width? If you look here, this class is going to be the numbers 0 through 4. That means that the numbers 0, 1, 2, 3, and 4 are in there. How many numbers do I have here? I have a total of 5 numbers. Look at the next one. 5, 6, 7, 8, 9. How many numbers do I have there? I have 5 numbers in there, right? The easy way that we can find the class list, if you don't want to write them all out like that, you can just subtract this number here minus that number there. So 5 minus 0 gives me 5. I could also subtract 9 minus 4, and I'll get 5, okay? So that's what we mean by class width. Okay, the next thing is they're not going to overlap. Notice this one ends at 4, this one starts at 9. This one ends at 9, that one starts at 10. There's no overlap there, okay? And then any piece of information is going to go into only one class. So meaning if I have the number 7, the 7 is only going to go here. It would not go in here because 7 doesn't fall in there, right? That kind of makes sense. It's sort of intuitive. So I'm going to scroll down again, and we're going to make a frequency distribution with a class here, okay? So it says in these problems, the data represents the approximate 2013 population in hundreds of thousands of people of the 20 most populous cities in the United States. Okay, so let me scroll just to get right there. And let's see if we can't figure this out. So it says, use the data to construct a frequency distribution with the first class. What it's telling me is that the first class is going to have a range of 16.0 to 19.9, okay? So if I know that this one ends at 19.9, this one here is going to start at 20.0, okay? Now, I need to find the class width. So if you remember, the way I can find the class width, okay, is by taking this number and subtracting that number. So I can say, look, let's 20.0 minus 6.0, that's going to be 14.0. That means that the difference between these numbers here is going to be 14. Well, if the difference there is going to be 14, guys, then the difference here should also be 14, which means I can take 19.9 and I can add 14.0. And let's see, 9 and 4 is going to give me 13. That's going to be 33.9. Okay. If I add another 14 here, that'll give me 34.0. If I add another 14 there, let's see, add 14, that should be 47.9. Okay. If I add another 14 here, so 34 plus 14 should give me 48. Okay. If I have, you know what, I'm going to just use my calculator here. Come on. Let's get it going. There we go. Turn it on. So let's see, where we were at 47.9. 47.9. We're going to add another 4, oops, not 17, but 14. There we go. That's going to give me 61.9. And I'm going to let you know, guys, when I'm going to stop, okay? So let's try that again. So now we have 48. We're going to add 14. That's going to give me 62.0, right? And then, let's see, let's take, oops, sorry, calculator right here. Let's take 61.9 and let's add another 14 to it, 75.9. So then this one here would have to be 76, right? Because that's going to be right after that. And then if I do that, let's see, one more time, 75.9 plus 14 is going to give me 89.9. Okay, so 89.9. Okay, the reason I'm going to stop there is when I look at my data that we have here, that was the biggest number we had. So I have to make my ranges so that I can include all the pieces of all of the numbers that are in my set, right? So one thing I want you to notice is that the way our numbers are organized, they're organized from the smallest one to the biggest one. That helps me a lot, okay? So let's take a look. We're going to look for all the numbers between 6.0 and 19.9. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers. So I have 16 numbers in that range, okay? Then I'm going to say, do I have any numbers in the range of 20.0 to 33.9? I have 1, 2, so there's 2 numbers there. Do I have any numbers between 34.0 and 47.9? I have 1 number there. I don't have any numbers between 48 and 61.9, so I don't have any there. Again, I don't have any numbers between 62 and 75.9, so that's going to be a 0. And then we have one number here, right? So guys, one thing we could do to make sure that we're doing this right, we could take these numbers here, and if we were to add them all up, let's see, 16 and 2 is 18, 19. There would be a total, I'll write it in green. So the total would be 20, right? And if I scroll up here, it tells me that this was the total of 20, right? The 20 most populated cities. This is all I'm really trying to do in this problem. Again, I wanted to work it out slowly because you have a problem identical to this in your homework, guys. I want to make sure that you're able to figure out how to do it. It takes a little bit of time. Excuse me. It takes a little bit of time. Go slow, and you'll be fine. All right. Okay. So let's see if we can do the same thing here. Look at my problem, and it says use the histogram below to answer the following questions. Okay, so it says, let me see if I can zoom in a little bit without it doing too much stuff. Let's see. Okay, here we go. I'm just going to come back up because I don't know why it always does that, but it does that. Here we go. This is the problem we was on. Okay, so let's take a look. See here? It says, how many homes were included in the survey? Okay, so guys, I want you to look here. These numbers here are referring to the number of TVs, okay? These numbers here are referring to the number of homes. So what that tells me is that there are 2 homes that don't have any TVs. There's 4 homes that have 1 TV. There are 8 homes that have 2 TVs. There are 6 homes that have 3 TVs. There's 4 homes that have 4 TVs. There are 3 homes that have 5 TVs, and there is 1 house that has 6 TVs in that house. That's a lot of TVs. Okay, now it's asking me, can we find the number of homes? Yeah, all we're going to do is add those numbers up. 2 plus 4 plus 8 plus 6 plus 4 plus 3. Okay. I'm going to grab my calculator again so I can do that. Let me scroll this over here. 2 plus 4 plus 8 plus 6 plus 4 plus 3. It's giving me 27, right? So there are 27 homes here. Y'all know what the Cholo said when the house fell on top of him? Get off me, homes. Okay, that's just a joke, guys. So it says, in how many homes were 4 televisions observed? So I'm going to go right here. 4 televisions. How many homes did we have? We had 4 of them, right? Okay, so in 7.3, we talked about mean, median, and mode. When it tells me here, what is the modal class? It's asking me, do we know which is the biggest bar here? Yeah, the biggest bar is that one there. When they're saying the modal class, they're actually not, they're talking about the bar that has 8 homes. But they're referring to that bar is the one that has 2 TVs, right? Okay, now part D says, how many televisions were observed? So this part, guys, I'm going to be real careful, okay? I'm going to do it this way. I'm going to say, look, so we have 2 homes that don't have any TVs. We have 4 homes that have 1 TV. We have 8 homes, excuse me, that have 2 TVs. We have 6 homes that have 3 TVs. We have 4 homes that have 4 TVs. We have 3 homes that have 5 TVs, and we have 1 house that has 6 TVs, okay? Fix that, looks like a 16, it's supposed to be a 6. Plus 1 times 6. Okay, so now let's go ahead and do this part. I'll write it in red. Well, 2 times 0 is 0, plus 4, plus 16, plus 18, plus 16, plus 15, plus 6. Right? I'm just multiplying my numbers there in parentheses. And now we'll go ahead and start adding them up. So 0 plus 4 plus 16 plus 18 plus another 16 plus 15 plus 6. And we have a total of 75 TVs, okay? So for number 4, there were 75 TVs, okay? Now, part E. Part E is asking me, can I make a histogram? I'm sorry, a frequency distribution. Yes, we can. We can make a frequency distribution. So what we're going to do is we're going to say, look, let's do it like this. The number of TVs, the number of homes. Okay. So we have 0 TVs, 1, 2, 3, 4. Let me see if I can clean up some of this mess here, guys, so that I can make this a little bit better. I'll tell you what, from here we had 27 homes. Okay. So let me get rid of this. There we go. Okay, 5 and 6. Okay, 5 and 6. There we go. Okay, so then all I'm going to do is I'm going to count. We have 2 TVs that don't have any houses, or I'm sorry, 2 homes that don't have any TVs, 4 houses that have 1 TV, 8 houses with 2, 6 houses with 3, 4 houses with 4 TVs, 3 houses with 5 TVs, and 1 house with 6 TVs, okay? All right, so that's how I answer my parts A, B, C, D, and E, okay? I'm going to keep scrolling here, and we're going to see if we can't figure out this one, okay? Give me one quick second. Okay, so coming back to this problem right here, let's see. It says car insurance. It says use the histogram below to answer the following questions. Okay, so let's take a look here. We have the annual amount in dollars. That's what each of those bars represent, and the number of students. Okay, so the first question says how many students were surveyed? So this bar represents 2, 4, 6, 8, 7. This looks like what? It looks like 3. There's nothing there, and this is 1. So I'm going to take those numbers again, guys, and I'm just going to add them all up. So let me move my calculator over here, turn this guy on again, and let's add 2 plus 4 plus 6 plus 8 plus 7 plus 3 plus 1, and we come up with 31. Okay, so we have a total of 31 students, okay? Now, the next question says, what are the lower and upper limits of the first and second classes? Okay, so one thing I want to point out here, these numbers that they're giving me, these are actually what we refer to as the midpoints, okay? Because it's the point, if you notice, right in the middle of each bar. Earlier, when we were finding the class width, we would take the first number minus sort of the next one, right? We would kind of do the same. We would do that. We're going to do the same thing here. But what we're going to do is we're going to subtract our midpoints. So if I notice the second midpoint, it's 701. The first midpoint is 650. If I subtract those two numbers, I'm coming up with the number 51. That just tells me that my class is going to have a width of 51. Okay? So I'm going to kind of draw the first bar right here, and I'm going to try to draw it kind of big because I want you to kind of visualize what I'm doing here. Here we have the number 650, okay? There's going to be a total of 51 numbers in here, okay? Well, this is already one of those numbers. So if that's already one of those numbers, then I'm going to have a total of 50 numbers, like 25 numbers going this way and 25 numbers going that way. So if I were to take 650 and I were to subtract 25, that would tell me that number there is going to be 625. And if I do the same thing here, then the number at the end would be 675, okay? So that tells me that the first class is going to have a width of 625 to 675. This would be my first class, okay? So now, if I'm going to find my second class, well, if you think about it, remember, this would be the number right after that. That would be 676, right? And remember, if I add 51 to here, I get that number, right? If I add 51 there, I'll come up with the number that I'm going to put right here. Oops, sorry. Let me grab my calculator one more time. Okay. And let's say, what's 675 plus another 51? 726. So let me write that in right here. Okay. So the first class is going to have a width, or the lower and upper limits, of 625 and 675. The next one would be 676 to 726, and we could kind of keep playing that same game all the way through, right? Now, Part C says, how many students have an annual car insurance premium with a class mark of 752? So I'm going to go to 752. It's asking me, how many students do we have there? We have 6. Okay. What is the class mark of the modal class? The modal class is the one that has the most, but it's referring to, so I know it's 8, that's the biggest bar, but what is the annual amount? That would be 803. Okay. Now, it's asking me, can I make a frequency distribution? Yes, I can. And it's telling me that, notice, look at the first class. It's going to be 625 to 675, which is what we came up with, okay? So look, I'm going to go like this, 625 to 675. I'm going to count the number of bars I have, guys. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I got to do this 8 times, okay? So look, 1, 2, 3, 4, 6, 7, and one more should give me 8. Okay. So then the next one we said was 676 to 726. I know the next number here would be 727. What I'm going to do is I'm going to start doing my bars. So I know if I'm at 727, if I add 51, that's going to give me 778. That's going to be the number here. Okay. If I add another 51, 829, that's going to be my number here. If I add another 51, I'm going to come up with 880. Okay. I'm going to keep playing this game, guys. I'm going to add another 51. Okay. I'm going to come up with 931. And I'm going to do that one more time. Add 51. And I'm coming up with 982. Okay. Now those are just giving me the first bars. Okay. Those are just giving me the first bars. So now I want you to think about, how am I going to find the second numbers, right? So the second numbers, I could do the same thing, right? I could say, look, if this number here was 726, what happens when I add 51 to it? If I were to add 51, I'd come up with 777. Another way I could do that is I could say, look, well, if this number was 778, the one before it has to be 777. So if this number is 829, that's going to be 828. If this is 880, that's going to be 879. It's going to be the one right before it. If this is 931, that's got to be 930. If this is 982, that's going to be 981. And then I'll go ahead and add 51 to that to get to my last number, right? So 981 plus another 51 is going to give me 1032. Okay. All that's telling me is that these numbers here would be the number that goes there, and the number that goes there, and so on and so forth. Now all I have to do is just copy the numbers that I have here. So the first bar has 2, 4, 6, 8, 7, 3, 0, because there's nothing there, and 1. And that's how I make my frequency distribution. Sorry, guys, it's a little messy. My hands are, I always have bad handwriting. But I'm hoping that the process and how we did it made sense, okay? And that, my friends, was 12.2.